Welcome back. Today we are going to talk about solution architecture. Now what is solution architecture? If you look at architecture terminology, you will find, if you look at architecture literature, you will find large number of architectures mentioned, like you will have software architecture, solution architecture, somebody talks of data architecture, there is logical architecture, there is enterprise architecture, system architecture, there is even code architecture. Now in this talk I am going to look at solution architecture. Later in some other modules we will look at some of the other architecture definitions or meanings of those. So what is solution architecture? Let us start with some examples. We are looking at enterprise level software, not so much embedded software. It is difficult to illustrate this example through embedded real time systems. So I am going to talk about typical IT application to illustrate what I am saying. So what we have in a enterprise class application is normally a process which the users follow. They try to accomplish something like maybe register for a course, issue a book out of the library, or buy something, or take some money out of the bank. So they use there is a process to achieve any of these objectives, and then there is software which drives some interfaces and people follow a certain regulated process. Now the right use of technology in the process is the important one, and technology is playing a component in the process, right. So the right level of use and the right place of use of the technology is very critical for the software to succeed. Otherwise people will not use it. If they use it, they will not continue to use it, or it won't be maintained, or further versions will not come, and so on. So let us start with this example. Let us say in a bank I want to withdraw some money. I go and present my check to the teller, and the teller verifies my signature. What does the teller do? Probably he or she pulls out my credentials from the database where I have given a sample signature when I opened the account. He will compare with the signature that I have put on the check and then say yes, it is authenticated, it is verified. I could actually use the computer to do the comparison of the signature as well. I do not need the teller to verify the signature. So the difference between these two solutions is, in the first case where the teller is verifying the signature, the computer is just used as a store and retrieve system. A scanned image of the signature is stored and it is retrieved. In the second case, when the computer itself is making a match and giving me yes or no, then there is a larger amount of software sitting there, more sophisticated, more complicated, with its own quality. There may be some errors, sometimes it may erroneously flag yes or no, right. There is a difference between these two solutions and the trade-offs are obvious, right. For example, one obvious trade-off is, if I make the computer system solve, then I may have to spend more money creating that software, right. It becomes a lot more sophisticated, but obviously I might get faster response times. The human need not have to, I do not have to depend on, let us say, untrained signature reader to make a call. Okay. Here is another example. Suppose I check a book out from a library, I issue a book and I want to take it out. In order to prevent unauthorized removal of books from the library, at the gate of the library, I may check if the book has been issued. There are many ways to check. For example, if there is a due date stamp on the book, somebody can look at the book. sometimes I can put a magnetic strip in the binding of the library which is checked by a sensor, and if it is not issued then there will be a cyan. Another thing I can do is to not check at all. Let the users take the book, having issued it in some issue counter. Now, these are three different ways of doing the same thing. Obviously, some solutions will work in some libraries, and each one has their own cost, right. So, somebody has to decide what is the correct solution for my library, for this particular library, whether would you want to check at the gate or not, and in which way will you check, right. There are cost and feasibility, technology level feasibility trade-offs. This is one more example from the bank. These days you have your accounts online, you can get your complete banking information online, but there are lots of people who are not online and they would like printed copies of their statements. So, there is the concept of a passbook in which you can maintain all your transactions. The bank may decide we will not have passbooks, okay. So, that is a decision made by the banker, and it has implications to the cost, and of course, the kind of users the bank is addressing, right. Here is one more example. Let us say I have a system, and if the system goes down for whatever reason, a software crash or hardware error or power failure or whatever, I would want an automatic failover. I want another system to take over. So, if I have to do that, first of all I have to have a hot standby. There has to be some communication between them where the standby machine is monitoring the main machine to see whether it is up or down. There may be a heartbeat ping going on between these two machines, and the system will, and every transaction that happens I need to make a copy, so that when the failover machine, the standby machine takes over, there is no loss of data. Now, this has cost implications. So, the standby machine is going to cost you some money, and maybe the total cost may double actually, right. The software gets more complicated, that means there is development cost, and then there is maintenance cost and so on. How do you decide whether you will have a hot standby or not? The decision will be based on the needs of the application. Sometimes the application may demand uninterrupted access to the software, and sometimes it is not so critical. If it is the functioning of a office in a 9 to 5 setup, there are 10 people, it is a small setup, they are all sitting in the same room. If the system goes down, somebody will get up and do something, right. But if it is a system accessed over the internet by a large number of people, and people in multiple time zones accessing some critical functionality, then I need a hot standby, right. So, it is a function of the application. So, what we have seen in these examples is basically certain set of requirements which are examined, and somebody makes a decision whether to build a piece of software for them or to manage them, okay. What do you mean by managed? That is, it is part of a process. If the machine goes down, somebody will get up and reboot the system. Some other process will not, some other system will not kick in automatically, okay. So, there is a set of requirements for an enterprise, and some of the requirements are met through either a piece of software, somebody writes a piece of code, that is what we are calling engineered, or that is met through a process where there are people and there is a set of actions that happen upon an event or to achieve certain objective. Okay. So, what we are doing is we are taking the requirements and dividing them to engineered and managed. Managed ones are the ones to be done through a process, some practices, and engineered ones are the ones which are done through some piece of software, hardware, or combination of both and so on. And that is the reason we exist, right? We are the ones who do the engineering part of it. So, we are going, so who will do the managed part of it? The enterprise in which the system is deployed, the people of the enterprise are the ones who do the managed part, and there is a process, there is a checklist of things, there is a knowledge of how to go and achieve something, there is a knowledge of what to do when something happens, right, or what is feasible or not, right. And who will decide all this? It is the solution architect. Okay. So, solution architecture is moving from the business goals that are there to, we can call them functional requirements and some process definition, and the functional requirements are passed to downstream to the software developers where they will go and build the system. So, I will leave you with a homework. Think of some examples where you can do some solution architecture and illustrate the difference between two solutions. See how they differ from each other, in what aspect. See you soon.